I'm curious how you guys saw this first one. You might not have done it the same way I did. How did you guys do this one here?
You set them to 0 and then solve for one side. Solve y. Fy.
Fy, okay. So you get x squared equals 4y.
And then y equals x squared over 4.
So y equals x squared over 4? Okay, I like it. So I like this idea. So you can substitute. So that's pretty much the way almost all of them will work. If you're not sure what to do. So if you plug this back in here, into this equal to 0, you get, well, I can take a 2x out, but let's see, 2x minus 2x times x squared over 4. Cool. Now if I multiply both sides by 2, this will come out nice, right? So it'll be 4x minus x squared equals 0.
X cubed.
X cubed. Yeah, thank you. Careful, I did something freaky for mine, but eventually I got here. And then that one's not too bad. So if you divide, take an x out. So the difference is squared, so you should get 0 and plus or minus 2. So you get x is 0, x is 2, x is negative 2. And for each one of those, when x is 0, y is 0. When x is 2, y is 1. When x is negative 2, y is 1. So you get 0, 0, 2, 1, negative 2, 1. I like it. Sweet. Now for this one, what's fx? Let's see. 4x minus 4. This is a nice one. You can see how you can identify that now because there's no mixtures of x and y. So I know this is going to act, it's going to be nice. Okay. And fy is 3 minus 12y. So what x makes this 0? 1. What y makes this 0? 1/4. Done. I really hope you guys understand why some of these problems you don't have to worry about the mixing because there's no mixing to begin with. X controls X, Y controls Y. You just slap those together, you're done. It's only when they control each other that you got to be careful. This one we already talked about, right? But again, fx depends on cosine, fy depends on sine. So there's no way in hell to make them both 0 at the same time. You're going to try to list, y equals pi over 2 plus or minus 2. No, screw that shit. I mean, there's just none of those are going to make the other guy 0. So there's no critical points. This is the one we were just talking about, right? This fx, you get 2x minus 4y. Fy, you get 8y minus 4x. They both say x equals 2y, right? Both of those say x is 2y, right? If you said each one equal to 0. So to make that condition hold, you just have to make sure that x equals twice y. That's an infinite number of points. They all lie on that line. So every point on this line is a critical point. And that's actually a very straightforward example. I mean, you can have a ridge that's the same height all the way across. So that's what this relates to. Or a trench, again, the same idea. That's not a very difficult thing to get down physically, right, in the real world. So critical points would be all points on pop. This one, it gets interesting. So fx, 3y, 2xy, y squared, fy, 3x, minus x squared, minus 2xy. A lot of symmetry between those two. Now there's a couple ways to do this, and it's kind of a mixture of the ways. So you can take fx and you can factor it, right? Now if you try to do this, let me show you something. If you try to take something, you set this equal to 0, I can solve for y then in a way, right? So you've got to be careful. So I would get y equals, if I add this over, divide by 2x, anyway, 3x minus x squared over 2x. Well, that's just yummy. And then I could try to plug it in. Now, why can't I divide by x? Because then I'd be losing the possible answer, right? That would be x equals 0. So I can do that as long as I put on the side x equals 0. 3 halves x minus 1 half, gather x. But I got to realize that x equals 0 is a possible answer. So that gets a little bit hairy when I'm trying to divide by a variable. I don't want to do that unless I realize that that's a possible answer. Now, what's a different way to do this? I can take my fx and I could take out a y, for example, right? Take my fy and I could take out an x. Just reorganizing it. I get this actually. Take my fy, take out an x, I get 3 minus x minus 2y. That's the difference there, yeah. So that's what was happening with yours. I couldn't see it. If you take an x out of my fy, I get 3 minus x minus 2y. These are not exactly the same. Oh, sorry. You guys actually want to see what I'm doing? All right. And you're all like, it makes any kind of sense. You guys still with me? Now, right now I can see some answers. So Renee, this is one I missed from yours. It was to cross things. It wasn't exactly the same. You see that? The 2's in the wrong place. But right here, y equals 0 makes that 0. X equals 0 makes that 0. So at the point 0, 0, these are both 0. So 0, 0 is an answer. How are we doing so far? Okay, and that's what I saw just a second ago. That x equals 0 was an answer that I had to take into account. So this is equals 0, this equals 0. So either y is 0, or 3 minus 2x minus y is 0. X is 0, or 3 minus x minus 2y is 0. Now between these two, these are not that horrible unless you write them the way I did. I get this answer here. Now you just have a system of equations that looks actually more normal than anything we've seen so far. Believe it or not, 3 minus 2x minus y is 0. 3 minus x minus 2y is 0. Could I, now this one I could just do elimination really if I wanted to, right? If you want to, it doesn't matter. So couldn't I just take this one and multiply it by -2? So then I get -3 plus 3x equals 0. So I get x equals 1. Are you guys with me? Okay. And then what would y be?
1.
So now if I plug this back in, plug in a 1, I get 2 minus 2y, I get y is 1. Let me slow down. This was a little weird, so I should. Where did these come from? They both came from combining the two, right? They didn't, I don't know how to say this. They didn't both come from just one of those. They came from both equations at the same time. So x equals 1 and y equals 1 makes both of these things true. Let's check it. 3 minus 2 minus 1. 3 minus 2. As long as x is 1 and y is 1, they're both going to be 0. They're both true. So the point 1, 1 works. And we already got the point 0, 0. Cool. How are we doing this? Really just, when I get to this point, these are just two lines. They're going to meet in one place, unless they're the same line. They're going to meet in one place. Let's get two critical numbers for that. That was a little weird. Trust me, that was a little weird. There's multiple ways to try to do that one. It's a little bit freaky. Okay. Anybody try part F yet?
I found the partial. I found the partial.
I did the partials, yeah.
All right, the partials. Okay, we give myself some more room. So to write this better, I would write x to the 1/2 over y to the 1/2. You could even write x to the 1/2 times y to the negative 1/2, right? Just to make it look more ready for taking derivatives. So what would fx be?
1 over 2 square root of x.
1/2 x to the negative 1/2, and then y to the negative 1/2 just goes for the right. Fy would be, yeah, negative 1/2 x to the 1/2 y to the negative 3x. I love it. So if you write it in a nice form for yourself, be nice to yourself. Write it. You don't have to do quotient rule, my God, or something weird. Write it as a product. Bring that bad boy up. Write them as exponents. That's the form you want it in for derivatives. Makes the differentiation a lot easier. All right, now let's really see what we got. We got fx is 1 over 2 square root of xy, and fy is, let's see, negative rad x over twice rad y cubed. Ooh, that's yummy. And I want each of those to equal 0. Now, obviously, neither one, this one can equal 0, but this one can't. You guys follow me? Now, what's in the domain of this? Yeah, y can't be 0. There's also like, no, x and y have to be the same sign, all this kind of weirdness. I don't know if you guys see that, right? Because you can't have a negative under the radical. So y can't be 0, and this is what that says. If x is 0, then this is undefined, but this would be 0. Do you see what I'm saying? So there's no place that's in the domain of this function where both of these are 0.
Or like critical points for function set defined
Yeah, but where is this undefined?
on the bottom.
Yes. So y equals 0 makes this undefined, but y equals 0 is not in my domain. X equals 0 makes that one undefined, but it doesn't make this one undefined. So there's nowhere that they both equal 0 or are undefined. You guys see that? So yes, I had multiple problems on here without critical points, but I don't care. I want to show you all the ways you could have a problem that has no critical points. It's actually kind of nice to have no CPs because then you don't have to do, number 2, you're done. They're asking you for that kind of problem, you're done. You don't have any critical points to check. Real quick, in order to do this, that's the problem from part A, right? In part A, we got, what did we get?
0, 0,
Yeah, we got 0, 0, 2, 1, and 2, negative 1, right? Or negative 2, 1, and 2, 1. We got those 3. Now, what's fxx? I need to know what that is.
2 minus 2y.
2 minus 2y. I like it. And what's fyy? 4. Cool. And what is fxy? Where'd it go? Sorry. Fxy. There it is. Negative 2x. Good. So now just for each one, for 0, 0, for example, if you do 0, 0, fxx would be 2. This is always 4, and this would be 0. So then you just do 2 times 4 is 8 minus 0. You guys see what's happening? So for the point 0, 0, that's one of my critical points. Are you still going there, buddy? Yeah. So pretty cool with these second derivatives. So 0, 0 is 0 in, you get 2. That's always 4, kick x. 0 for x, that's 0. 2 times 4 is 8 minus 0, so d is greater than 0. Then which one of these am I in? Well, fxx was greater than 0. Therefore, this is a local Greater than 0, cup up. Min. I like it. You guys with me? I mean, that point it's easy. Should hopefully be easy. I'm going to give you this little box. It's crazy. Being so nice because all the work is the critical points. That's where the work goes in. And you just do that for each point. You plug in 2, 1, you plug in negative 2, 1. Plug in each point and see which situation you're in. So you can see what, is it a min, is it a max?
So you just multiply.
You have all points of the
You take any point. You take any point.
Oh.
Yeah, because they all are tied, right? So if you want to know what that is, you just have to find a single one because they're all the same. I like it. Oh, for a problem like part D, the one that had the x equals 2y? You mean? No. All right, so I've finished out checking out 0, 0. How do I finish out number 2? I now check out 2, 1. Right, so 2, 1. This would be 2 minus 2. I mean, say 2 minus 2, 0. Right? You guys with me? If I plug in the point 2, 1, so y is 1. fxx would be 0, so I don't care what fy and y is, that's 0. Minus fxy squared, so this would be negative 4 squared 16. It's going to be a saddle point, yeah. Because anytime this guy is 0, it's going to have to be a saddle point. I like it. Oh, this is if d equals 0, then no, that's right. And then negative 2, 1, you can plug that in and see what happens. That should be the easy part. That's just a formula. You plug it in. You see what the result is. Again, that's the easy part. The hard part is the critical points. So if I plug in 2, 1, I get saddle points. If I plug in negative 2, 1, I'm going to get saddle point again. You guys see that? Because again, it's going to be 2 minus 2. It's still 0. All right. What time we got? We'll do number 3 next time. I don't know if you guys even made it to there yet or not. Just to remind you guys, just use formula square root shit.
Yeah.
So do d squared. If you minimize d squared, that minimizes the square root. That's the trick. So we don't have to deal with that large ass radical for the derivatives. Oh my God. Thank you God. Okay.
Basically, from what you're graded.
I mean, I have one of
Yeah, what do you mean? Yeah, you got to reference the heights. Yeah. The curve, I don't know what you mean. The surface would be better. Curves are these, and it's not what these are doing. It's what the surface is.
So that's the impression that you want to rewrite it.
Well, and be careful. I need to see you as we move in the x direction. The height is decreasing. Beautiful. Yeah. Yeah.
So,
Oh yeah, what's that doing there? Where'd that come from? It's negative. It's 3. Well, no. fx is 3 over. Right? In fact, I don't know what. Yeah, this is not, there's no paths. I'm not asking you to show that it does not exist. You only do paths if I'm asking you to show it doesn't exist. You just factor these, and then you can plug the point in. Right? Find that. So I'm telling you, that's kind of like me saying it exists. Not, if it didn't exist, I'd say show that it does not exist. Like number 4. Yeah. Yeah.
This is,